When doing geometry questions, you should always redraw the figure if one is given, since unlike me right now, you can't write on the computer screen. And if no figure is given, then definitely draw one. So step one for geometry is draw. Once you draw your figure, you should fill it up with information as much as you can. So step 2 when doing geometry is label. For example, let's start with the fact that here TS is the midpoint of QS, and U is the midpoint of RS. This means that TS has to be the same length as QT, and since we don't know what length that is, let's make both QT and TS equal to X. This is what I meant by labeling. You put your information on the figure. Similarly, RU and US have to be the same length because U is the midpoint of RS, meaning it cuts it in half. So let's make both of these Y. To make things a little clearer, I will draw this triangle as two distinct triangles. So here we have the big triangle, and here we have the small triangle. This is QRS. This is TUS. QS, as you see, is equal to 2x. RS, as you see, is equal to 2y, whereas TS is just equal to x and US is just equal to y. The fact that both of these triangles share angle S, which is exactly the same, means that they are similar triangles. Therefore, they are proportional. Proportional in this case means that their sides are in a ratio of 2 to 1. This is because RS is twice as big as US, QS is twice as big as TS, so the ratio of these two sides, RS to US and QS to TS, is 2 to 1, and the angle in between these proportional sides is the same. Therefore, the triangles are similar. All this means is that all of the sides are in a ratio of 2 to 1 between these two triangles, which means that we'll make this side Z and this side 2Z. Essentially, QRS is a zoomed in, or rather magnified version of TUS. Now that we know this, we can use this fact to figure out the area of TUS. How do we do that? Well, suppose that there is a square with sides of 10. So 10, 10, 10, and 10. Suppose there's another square with sides of 5. So 5, 5, 5, and 5. The area of the big square is going to be 100. The area of the small square is going to be 25. Notice that these two squares are also proportional, meaning their sides are in a ratio of 2 to 1 as well. So the squares have sides that are in a ratio of 2 to 1. But their areas have a different ratio. Areas have a ratio of 4 to 1. 100 to 25 is 4 to 1. This generally holds. The general rule is that if sides have a ratio of x to 1, the areas have a ratio of x squared to 1, meaning the ratio of the sides squared is the ratio of the areas. This holds true for similar two-dimensional figures, so squares, triangles, rectangles, etc., that are similar. And we can use this information to now solve for the area of the small triangle. We know that the area of this big triangle is 40. That's what the question tells us. And we know that the area that these two triangles are similar, and that the ratio of their sides is 2 to 1, which means that the ratio of the areas must be 4 to 1. So if the area of the big triangle is 40, the area of the small triangle must be 10, which is answer choice A.